Hello and welcome to finally the next lesson in Commodore 64 assembly language tutorial. Yeah, it's been a while. I'm not even going to make any excuses because you don't want to hear it. But we are back with a new lesson. So what are we going to cover today? Right, well what we're going to do is we are going to look at how we can use the kick assembler macro feature and also the importing features to actually make ourselves a set of like reusable libraries. Okay, so we don't have to keep repeating the same old code each time we want to do something, whether it's in a different program or repeating it once in the same program. And so we can like build ourselves up a library of usable macros or routines. So it just makes life much quicker for us. So without any further ado, let's get started. So what we want to do on this is video 13's file. We're going to just set up our standard game program, so to speak. So what that'll involve doing, that will be just giving ourselves a basic set interrupt code. We won't get it to do anything at the moment. We'll just put some placeholder stuff in there for the interrupt, which will run on Raster 0. So that will run once, every time the screen redraws. We'll disable all the kernel interrupts. Then we will switch out BASIC, switch out the kernel, and clear the screen, that sort of thing. Just basically setting up the structure up ready for a new game, for example. Okay, so let's just make sure this is nicely zoomed in. So what we're going to do, I'll set the structure up how we're going to do it normally, and then we're going to jiggle some stuff around. So we can move some repetitive stuff into macro files, etc., etc. Okay, so the first thing I'm going to do, which I haven't done before, I put this declaration in. Because if we're going to have multiple files that we're going to import, we don't want things being imported twice. So this directive, you put it on all your files. If it's referenced in more than one place that you're importing it, it will only import your file once. I mean, this is the root file, so it doesn't matter so much, but it's just good practice. Okay, so this is where I want my code to start. So init, and we'll start that up 1000 hex. Okay, so init is here. Okay, and RTS for now. Okay, so oh yes, we've got to put that there. So what we do is we want our basic up start 2. So it does our syscall, and that will basically sys it to there. This will do absolutely nothing, and I can prove that by build and run. And yeah, it's doing absolutely nothing there. See? It's my Commodore 64. You can see where I've edited the kernel just to change the text. Okay, right. So, what do we want to do? Right, what we would like to do, we want some basic code that will run every time the Raster hits line 0. So we'll just create a skeleton for that here. Okay, so let's split it up into section. Vars section. Ooh. This is where we have like bytes that we're going to store stuff in, like the speed our character's going, what level number they're at. Okay, so we've got a variable section, IRQ section. This is our interrupt handler. So let's do our IRQ. So this is the code that will run every time it will, whatever the program's doing, when the Raster bar hits 0, Raster line gets to 0, then this code will run. Well, we haven't set it up to do that yet. So what we'll do is we will push the accumulator onto the stack, transfer the X register to the accumulator, push that onto the stack so we don't lose anything. Transfer the Y register to the stack and push that. Okay. Let's put a placeholder here. IRQ code goes here. Okay. And then what we want to do, once we've finished our code, we want to restore the accumulator and everything back. So first of all is it's the Y register because it's last in, first out. So we will pull from the stack to the accumulator, and we will transfer the accumulator to the Y. We'll do the same there. Transfer it to the X, and we will do it again. And then we will return back. Okay, so let's call it acknowledge. We've got to acknowledge the interrupt as well, haven't we? So we'll decrement the interrupt status register. Okay, and now if you look, it doesn't understand that because we've not pulled in our constants or anything yet. Okay, but don't worry about that. We're going to sort that out in a minute. In fact, I'll do it now because that squiggly line's annoying me. There we go. Okay, but we're going to make ourselves a nice collection with everything in. Okay, so again, this is going to do nothing. Okay, so what now we want to do? We want to set this interrupt up. So this is going to be our code that will do something. Okay, that will set the start our program up. So let's just put some comments in. Start up and init disable BASIC plus kernel set up IRQ. There we go. Okay, so what we're going to do, first thing we do is disable all the interrupts while we do this. Set the interrupt to disable. Okay, that turns them off. And we're going to disable the CIA interrupts. So we've covered this in previous video. So we were going to load the value, I think it's hex 7F, and we store that in the interrupt register, and 1 and 2. That's both the interrupt registered CIA. I think it's via 1, via 2, something like that. Anyway, I can't remember now. We covered it before, and I haven't had enough coffee yet to remember that. But this is our standard routine. So let's turn those off. Right, create interrupt at Raster line 0. Okay. Oh, we got enable Raster interrupts, and so we've disabled all interrupts at the moment because now we've got to enable Raster interrupts. So we load I think it's Raster sprite reg. We did this before and we just set bit 0 on it. So to set bit 0 is, we'll do it in binary. 1, 2, 3. Oh, no, binary will be that. 1, 2, 3, 4, 5, 6, 7, 8. So it'll keep all the other bits as they were. It just enables bit 0, which is this. So whether it's 0 or 1, it will be a 1. Okay. So now we've got to. So that's right. That enables Raster interrupts. So we'll cut that. We'll keep this nice and commented, so we know what we're doing. Great. Raster interrupt at line 0. So we've got two things to set. We've got, because there's more than 255 raster lines, there's 300 odd, 320 I think in PAL, something around there. We've got to set it in two places because it's a 9-bit number. So we're setting 0 in two places. So that is let's load the accumulator with 0, and we store that. This is the 8 bits of the 9-bit number. That's there, isn't it, in the raster line? So that's where the interrupt is. So it'll be there, and then we've got to load the accumulator with the value whatever's in raster line MSB. Okay, and we need to turn off the bit 7. Okay, so we need to AND that with there. That's bit 7 and 6, 5, 4, 3, 2, 1, 0. Okay, so the others will stay as they are because we're ANDing, we're not ORing, and that will be set to 0. So we've got a 9-bit number. There's the first 8 bits of it, and here that's the 9th bit here. So we're setting that to 0. Okay. So we store that. So that's now set up our interrupt at raster line 0. Okay. Now the last thing we need to do is tell it that when we get our interrupt to run this code here in IRQ1. So if we remember from a much earlier video, we load, we got a set of addresses called the interrupt execution low and high because it's a 16-bit address. Okay, and that basically tells it where to go when an interrupt is triggered, which is when it's a raster line 0. So let's put run IRQ1 every interrupt. So we load the low part of the address for IRQ1 into the accumulator. Oops, we want it as a number. And we're going to store that in interrupt execution low. And I think no kernel because we've turned the kernel off. There's a slightly different address there. Okay, if we look in the constants here. There, FFFE, FFFF. Okay, because we're disabling the kernel. This is where it is normally when you've got the kernel on, but we're disabling the kernel completely. So we're doing it all ourselves. Okay, so that's the low byte, low part of the address. So we load the high part. Okay. And then we will store that in the high part of the address. Okay, so what it will do, let's save that. Every time raster line gets back to 0, okay, what it will do is the interrupt to be triggered, it will look up the address here, the 16-bit address in this pair of addresses, and it will run that code. So that'll tell it to go to here. It will preserve the registers because we've written code to do that. It will run whatever code we've got here, and then it will acknowledge the interrupt, restore the registers, and then RTI, it will go back to whatever it was doing. Okay, so if we run this, it should do nothing. So let's see what happens. There we go. It pretty much does nothing. It doesn't even return us to BASIC because we've just switched it all out. Okay, so it's doing nothing. So why don't we, just as a test in here, let's just include the border color. So let's the Vic2 constants for now. So we want border because I copied and pasted this a while ago. It's got the American spelling of colour, but it doesn't matter. So let's just, to make sure this is working, every raster interrupt, it will increase the border colour. And that isn't working. So what's our problem here? Right, I'll tell you what we haven't done. We've not actually turned off BASIC or anything else like that. And we've not enabled our interrupts. So I'm being stupid. So let's switch out BASIC by doing this number and storing that into address 01. We've covered this in previous video, and obviously we need to re-enable our interrupts here. So let's save that. Okay. Oh no, what else I've done? This should be high. This is a typo here. Right, I know what I've done here. Okay, so I've corrected this, so it will store the low in the low bit and the high in the high bit. Okay, which is it was the typing on IntelliSense. Okay, so we're disabling BASIC and Kernal here. Okay, we load that address into this special register, which we've discussed in previous videos. We will then clear the disabling of the interrupts. Now we've set all this up, and I've put an RTS there, but obviously there's nothing for it to return back to. So let's just pretend that's our program initializing, and this is our program starting. So we're going to jump. So we're going to get it to this is our loop. Okay, so it's just going to loop back and jump to itself there. Okay, so if we run that now, there we go. And we've got a nice flashing border. Have you noticed there's no screen tearing because it's doing it once every raster at naught, so it's timed perfectly well, so we don't get the screen tearing when the border changes during the loading screen. Okay, so this is doing what we want. So this is our main program loop, but this we might want to do this like for pretty much every new program we write. Okay. So we give it an IRQ, we give it a basic IRQ. We can add different points in IRQ1 where it creates different raster intervals. But this looks like this is pretty much going to be standard for all our new code. So why don't we make that a macro so we never have to type it again? So let's create a folder. Okay, I'll do it here. Okay, we're going to call it libs. Okay, so in here we will create a file, new file, new Java file. Where's the new file? Let's do it there. So we'll just call it startup.asm. Okay, so in this, what we want to do is we want to do a macro. Macro. And we'll encapsulate it like that. We'll do that for all our macros so that any labels that we put in for loops can be reused. Okay, labels like this in it, ack and loop. Okay, we although we haven't got any, I always like to do that. So what we will do is we'll copy all of this, we'll cut it. Okay, and in our startup we will paste it there. Okay, well, what we want to do is see this IRQ here. IRQ1. Okay, we need to make that a variable, so because it might be different every time we're gonna call this. So let's put in a variable IRQ1. So we pass the address of the IRQ1 to this. Okay, and then that way it will when it references it there, it's referencing what we've passed into it rather than something that may or may not be there. Okay, right, we're going to do our usual import once. Okay, and I think now we've done that. Yeah, we'll just copy these. Okay, it won't know where they are because this is in a separate folder. So what I'm going to do, I'm going to copy these and put it in the libs folder. Okay, we're going to have all our files that we reference in here in this libs folder. Okay, so where are we on here? We are in, where's startup? Okay, let's make these. That's import once is on there. That's import once is on there. Okay, I don't know why it's saying that. Let's just save that. There we go. Now, what we're going to call our macro? Let's call it standard init. Okay. So, as you see, we've got 3 files in our libs folder. So why don't we import, rather than importing all 3 of these when we're doing our video, see, like we're importing 2 of them here, we don't really want to do that. Let's create another file in here. Okay, and we call it import libs.asm, and in this one we will import once and we'll import everything here. So constants, vic2, see, vic2 constants, and startup is there. Okay, so if you notice in startup we've imported these constants and vic2 constants, and we're going to import it there. We've imported it here so that we know that these values are correct, but that's why we do this import once, because we're importing it in more than one place and we only want to import it once. So Kick Assembler is clever enough to only import it once. So this will import everything. So on here, if we get rid of this, libs import libs. Okay, there we go. So that now references everything. Okay, but it doesn't do anything. Look, we've got nothing here in our init. So what we need to do is call our macro. And that's simply a case of just going standard init, and we send it the address of IRQ1. So now, as long as we've imported this file here, okay, we have access to all our constants, we have access to the vic2 constants, and we have access to this macro, which is the standard initialization. So let's save that. Let's just do a quick test. And there we go. It's flickering through all our border colours absolutely fine. Okay, so our next sort of reusable bit of code we want to do is going to be 2 things. One will be filling a certain amount of memory with a certain value, okay, up to 255 times. Okay, and the second routine will be we're going to use that in order to initialize the SID chip. So on the start of a program, we want to like initialize the SID chip and clear the values and turn the volume levels to maximum. So let's go back into our libs folder and we'll create a new file. And we'll call it memory.asm. Okay, import once. Okay, and we probably don't need our constants here. So let's create a macro, and we'll call it fillmem. Okay, let's do our camel case there. Okay, so our arguments, we want the starting address, we want the byte value that we're going to fill it with, so it could be like zeros or whatever, and then and the count. Okay, how many times? So we're going to give it a starting memory address, a character, and how many bytes we're going to fill it with. Okay, so let's encapsulate that. That way we will load the byte into the accumulator. Okay, and we will load the X register with the count. Okay, let's put a loop there, label there. Okay, so we will decrease the X register, store the accumulator in the memory address, comma X. Because don't forget, we're decreasing it here because it's an index that starts in 0. So to do it 10 times, okay, we'll be sending it the value 10, but we want it to count down from 9 to 0. So we'll decrease it there. Okay. And if it's not 0, go back up to the loop. Okay, so very, very simple exercise there. Okay, so what we're going to do in our import libs, okay, we're going to add memory. So now we've got a nice library coming up here. Okay, so now what I'd like to do is in the startup one, I will do initializing the sound. Macro init SID, and there's no parameters here. Okay, so we're going to do fillmem. So we give it the start address of the SID, which I've stored as, I'm sure I've stored it as SID mem. Okay, we're going to put the 0 in because we're going to fill it with 0, and we're going to fill it with 24 times with 0, starting at this address here. Now, if you notice here, it doesn't understand that because we need to import it. I mean, it would do when it runs, but we want to just import it there so we can sanity check our code. Okay, so that's going to run our new fillmem routine. So it's going to start off there, and for 24 subsequent bytes in memory, it's going to put a 0 in. Okay, then we will load the accumulator with the number 15, and we're going to store it in SID vol filters. So that's basically turning it up. Okay, so now we've got initializing our SID, and we should hear that pop. So what we could do here is we can either put it at the end of that, or we can just call it from here. I don't mind actually calling it from here. Okay, and it's SID. So let's just see if that works. There we go. Hear that popping sound? That was us initializing the SID. Okay. So the next thing I'd like to do is clear the screen. Yet again, that's something we're going to use time and time again. So let's create a new file here. Call it screen.asm. Oops, I've completely mistyped that. .asm. Import once. Okay, so we'll probably from here, we will probably need the constants. Vic2. Okay, so let's create one called fill the screen. Okay, and we can fill it with whatever character we want. I mean, to clear the screen, we fill it with the space character. That's how that normally works. So macro fill screen. Okay, screen address, because we can move the screen address around, and the fill byte. Okay, that is the character that we're going to fill it with. So we're going to do this 1,000 times for the screen. So we will load the fill byte into the accumulator, and we will load the X register with 250. Okay, because we're going to do this exactly 1,000 times so we don't overwrite our sprites by going slightly over. So we'll create a loop here. Again, because we're using loop multiple times, because we've encapsulated it here, it won't give us a duplication error. Okay, so we're going to do the same here. We're going to decrement the X register because it's going from 0 to 249. Store the accumulator in screen address, comma X. Oh, I'm being IntelliSense. Okay. Store it again in screen address plus 250, comma X. Plus 500, comma X. This is all assembler directives. This addition, it won't assemble like that in the code because it will know the screen address, and it will know, and it will have added 250, 500 there to it. Plus 750, comma X. Okay, here we go. That's a standard fill screen. And if it's not 0, then go back up to where it says loop. Righty-ho. Let's give ourselves another macro. Okay, this would be a nice one in our screen. Let's call it screen, or prefix to that so we know what we're doing. Set colors. Okay, so this will do. Oops. This will set the background color and the border color. Okay, so this will be a nice simple one. Okay, so we will do load the accumulator with the background color, and we store that in screen color, which we've set up in our constants before. Load the accumulator with border color. Store the accumulator in border color. That is literally it. That is our macro. That's how we set the colors. So let's put these to some use. Okay, so in our import libs, okay, we need to add the screen. Okay, so what we'd like to do here in our program, okay, this is our init. Okay, so what we'd like to do is, let's see, we've done our init. Let's do it in here. Okay, let's clear the screen. Or actually, we'll set the colors. Screen, set colors. Let's make it black. So it's our border color and our background color and our border color. We've set these constants up anyway. Okay, and then we want to fill screen. Okay, and screen mem. We're not changing the screen mem here. We're still going to be 0400 hex. And we want to fill that with the character of space, which is the number 20. Okay, in hex. Okay. Let's see if this works. Oh, something's not right. Ah, I know what it is. Look, why set the border when we're going to keep messing around with it? Okay, so let's just take that out. We were just doing that to test our interrupt code. Okay, and we don't really want to set it every time. We're going to be jumping back and setting it. So let's just call it loop, frog loop. Okay, so that's there. Okay, so it's going to run this once, and this is the game loop that keeps repeating, even though, look, we haven't even got any logic in there or any sort of code in there yet. So this should work fine now. There we go. It's cleared the screen and set it all to black. Okay, so the next thing we want to do, we'll stick with the screen library. Now let's write a little macro to actually print some text to the screen, and in whatever color we want as well. So we'll call it screen. You see here I've used Python case, and before I've been using a camel case. It shows you how many different languages I have to program with on a day-to-day basis for work. Screen print text. Okay, so we want the screen, the mem address where we want to print it. See, I'm messing these around again. Screen mem address, that's where on the screen we want to print it. Okay. Text address, that's the address of where the text is stored to read it from, to put there. Color mem address, and then the color. Okay, I think that's everything we need. Okay, so we load the X register with 0. Oh, I hate that. Okay, we'll load the Y register. Might as well make some use of it with the color. That's the color. Let's make this more. Okay, so put a hash because we're loading it directly in there. We're not loading it from an address in memory. Right, let's put ourselves a little loop here. Okay, so load the accumulator with the text address. X, if it's okay. We normally terminate our text with a 0, so that's finished, so that's be our finished there. So if it's 0, then we've done our text. Okay. Store the text into screen mem address offset with X. Okay, so 0 at the moment. It'll just go through. Stop filling that out for me. Okay, we will transfer the Y register, which is our screen color, and then we will store that color mem address. So we're X. Okay, that's it. Increase the X register, and then jump back to the text loop. Okay, so bog standard routine. Okay, so it's going to put the text into this address. It reads it. It will keep reading it byte by byte until it encounters the 0 at the end. Okay, and then while it's doing that, it will also put the color as well in the right place. So it loads the color into the Y register, transfers that into the accumulator, and stores it. Okay, and it keeps running this loop. So let's save that. Okay, so here let's do screen print text. Oh, we haven't set any text up, have we? That's hello text is there. How do we put that in normally? Yes, dot text, isn't it? Hi everyone. And then we'll finish it with a byte of 0. Okay, that's our terminator. So we will screen print the text. Okay, so it's screen mem. This is 0400. Let's add 12 to it. So let's just offset it a bit. Okay, the address of where our text is hello text. Color mem is always the same, so because we're offsetting that by 12, we'll offset this by 12, and let's do it in yellow. Okay, so let's give that a test, and that hasn't worked. What have we done wrong? Okay, I know what I did wrong. Stupid mistake. BNE finished. Okay, it should be BEQ. So branch if equal, which means a 0 flag set, and it won't set the 0 flag until it gets to the end of the text. So it wasn't doing anything. So let's just change that back to BEQ there in our macro. Okay, we'll go back to here and we'll run it. Oops, hi everyone. There we go. That's there. I know what that is because I did put a breakpoint in here. Let's take that out. Okay, and that hi everyone should not have a capital H because it's the Commodore 64, isn't it? And we haven't set the character set to the lowercase ones. Okay, so let's run that. Hi everyone. Okay. So now we can put quite easily. Now we've got our macros. We can, using one-liners here, a bit like BASIC, we can set the colours of the screen, we can clear the screen, we can print text anywhere on the screen in any colour. Okay, we can initialise our program here and the sound as well. We can get that all initialised. Okay, so apart from our interrupt code, which is doing nothing, okay, everything we're now doing in our main program is just these few lines here. Okay, because we've got all these macros, all the heavy lifting code is in here already. Okay, so what do we want to do now? Okay, what do most games need? Yes, they need a sprite, don't they? So let's add some sprite routines in. Okay, so sprites. Let's define a sprite. We'll just do one from. We won't do some animation for now. Okay. We'll do a block 200. Okay. So as you know, the VIC sees the memory in blocks of 200. And there's and they're blocks of 64. So we want it at block 200, so 200 times 64, folks, mental arithmetics. Okay, 200 times 64 is 12,800. Okay, so at memory address 12,800, Sprites 0, just as a reference. Okay, so I will paste these. Okay, so this is my sprite. I just quickly knocked it up in Sprite, mate. I did that off camera, so you can see that and see if you recognise what it is when we put it on the screen. Okay, so as you remember back in my early videos, what we do is we need to point the sprite pointer at block 200, which is this address here, for sprite 0. Okay, so let's create ourselves a reusable macro. Okay, let's do a new file, sprites.asm. Okay, we'll do our import once, and we'll do our constants as well. Just constants there. Okay, now what we will do, let's do a macro to set the pointer for the sprites. So macro sprite set pointer. Okay, so we want the sprite number there, and the block. So the block number, the block of 64. Okay, so let's encapsulate that just for good practice. Okay, so we will load the accumulator with the sprite number. Okay, as you know, we will load the Y register of that. So we load that with the Y register, and I'll show you why. Okay, we load the accumulator with the value of block. Okay, and all we're doing is we're storing that. Store that in the sprite pointer address. Okay, that's for sprite 0 because there's 0 to 7, but we're going to offset that. They're all sequential for each sprite, so we're going to store that in comma Y. Okay, so if we're setting sprite number 3, for example, it will do sprite pointer 0 plus 3, which is the same address as sprite pointer comma 2. Okay, so, well, actually that'd be plus 2, but yeah, you get the drift. It's offset. Okay, so we're only ever going to need this. That's the start of the sprite pointers, and adding it to that. Okay, we also want to turn the sprites on, don't we? Sprite enable. Okay, so sprite enable, we want the sprite number in there. Okay, now, a way we can do this is the sprites, whether they're on or off, for all of them is stored in 1 byte. If you remember back to my earlier video, so it's a binary byte like this. That's them all off. Okay, that sprite 0 on, that sprite 0 and 1 on, etc., etc. What we want to be able to cleverly find a way of turning on just the one we want with the sprite number we want. Okay, so I reckon if we did sprite sprite number mask, okay, So this is going to be a little area of memory. Okay, so we're going to have each sprite byte. Okay, so 5, 6, 7, 8. That's sprite number 0, our first sprite. Okay, so what we're going to do here is set one of these up for each sprite number. So that's sprite 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, but what we're going to do, we're going to have just the bit set for each sprite. Okay, so nearly there. And what this will do, okay, say we want to turn on sprite number 8, okay, or number 7, because it's 0 to 7, okay. We will send it the sprite number, which in this case would be 7. Here, this case would be 7. Okay, we will look up sprite number mask and the 7th one, so that's 0, 1, 2, 3, 4, 5, 6, 7. So that'll be this one. It will look that one up, and then it will OR that with the sprite enabled register, which is the address that you turn them all off and on. And because it's an OR, everything with 0 it'll keep as it is, everything with 1 it will turn on. Okay. So let's look at the best way we can do that here. We can simple. Let's do exactly what we did here. Sprite number. Oh, LD. Okay, that will load the sprite number. Okay, load the accumulator with sprite mask, Y. So that will find the appropriate one of these for whatever sprite number we're using. Okay, we will OR that with whatever is in the sprite enable register, which is all of them. And then we will store that value into sprite back, having OR'd it. See, IntelliSense doesn't work when I want it to. Okay, so now we're probably not going to see anything, but in our here, it's not going to be in our loop. Let's include import our new sprites macros here. Ooh. Oh, for God's sake, the IntelliSense. Rubbish, garbage, junk. Right. Okay, so sprite. Sprite set pointer. So sprite 0. And we're going to point it at 200. So that's now pointing the sprite 0 pointer here. Or here for this sprite. Okay, and sprite enable 0. Simple as that. Okay, so again, we're using all this nice structure to keep what we see here nice and simple. Well, we need some other things on the sprites. We need to set the colour for the sprite, don't we? For this example, it will just be a single colour sprite, but we can set multicolour at some point. So let's do a quick macro here. Sprite set colour sprite number, color, load the accumulator for the sprite number. We'll load the Y register because we're going to use the same technique. Okay, load the accumulator with the color. Okay, and because the sprite color addresses are all sequential, okay, which I can show you in a second. Oh my god, sprite multicolor. Okay, 1 and 2 are multicolors for that apply to all sprites. Number 3, multicolor 3, from 0 to 7 are the actual unique color of each sprite. So we will set sprite 0, but we will offset that with the sprite number, which in this case is going to be 0 anyway, but it will allow us to reuse that. So let's, in here, we will just sprite set color 0, comma, let's make it white. So we've set our sprite up here at the right pointer address. Okay, we've turned it on, we've set its color. Now we just need to set its screen position. Right, if we look back at our constants, okay, which has got all our vic2 addresses, if you can see here, okay, each sprite has an X address and a Y address, okay? So I'm going to have to use a slightly different technique when setting X and offsetting the sprite number, okay? Because unlike this, where they're all sequential, so you just offset it with the sprite number, so adding a 0 to this address gives you that, adding a 1 for sprite 1 address to that gives you that. This, we're going to have to do it by 2. So sprite 0x and sprite 1x addresses are different of 2. So that's one challenge. We've got that with the Y as well. See, they're 2 apart. Also, because there is more than 255 pixels long in the screen, there's an extra byte here, as you know, which has got, for each bit, it has a 1 or a 0 for each sprite, making that combined with that to be a 9-bit address. Okay, so if the sprite is like over on the right hand side of the screen and it's sprite 0, that means this number here, okay, this one will be set to 1. So we're going to have to do something similar to and use our mask for this. Okay, so what we want really in our sprites, we want to macro here, sprite set x set x, y, we'll just call it set x and y. Okay, so we want the sprite number, x pos, y pos, and then h x pos. Okay, which is a high bit for the sprite, depending on how far along the screen it is. Okay, now let's get over the first challenge. Okay, so we can't just load the accumulator, load the Y register with the sprite number, okay, and load the accumulator with the X pos, okay, and store the accumulator sprite 0x, comma Y. We can't do that because it will overrun the sprite number 0. That's fine, okay, but for sprite number 1, this address here will be setting the Y address for sprite 0 because it increases by 2. So what we need to do, we need to multiply this number by 2 before we do this. Now we can't do that if it's in the Y register. We can't multiply by 2 at all. Okay, so what we need to do, we need to load that into the accumulator. Okay, and then we do an ASL, which is an arithmetic shift left. Okay, and what that does, say this is our number, okay, ASL moves everything left, like that. Okay, so you see it's shifted left. Okay, it's not rotating, which puts the carry bit into there. It's arithmetic shifting left. Okay, so it just does that, which is an effect, because it's binary, that has the same effect of multiplying by 2. So you can see this is binary for 1, this is binary for 2. If we did it again, we would get this, which if you look is binary for 4. Okay, so that's what we're going to do. We're going to load that into the accumulator, multiply by 2, and then we're going to transfer the accumulator to the Y register. Okay, then we can load the X pos into the accumulator. We can store that there. We can load the Y pos into the accumulator and store that. Okay, into sprite 0 Y address and offset by that. Okay, so that should do it. Okay, so we've got the X position and the Y position fixed. We have not got this. Okay, so what we need to do, okay, is reload the well, let's see. Okay, let's add a little finished here. Okay, so let's load the accumulator with whatever is in HXPOS. Okay, BEQ means if it's 0, we just don't care. We won't run anything. That means the sprite is in the you know, the X position of the sprite is 255 or less. Okay, so let's load the Y, okay, accumulator with the sprite number that's not divided by 2. Ooh. Oh, what I'm doing, sprite number, so the non-multiplied by 2 number. Okay, load the accumulator with the sprite mask. Oh my god, I can't type today. Sprite number mask, because we're going to do the same thing. Come on, white. Okay, because we're going to use that, and we're going to OR that with sprite. MSBX. So that we're doing effectively exactly the same in here as we did for turning them on. So we're setting the bit for the appropriate bit for the sprite if its X position is greater than 255. Okay, and then we will store the accumulator back there. Done. Right, shall we give that a little test? Okay, let's go back to our video 13. So let's sprite set XY, so 0. Where shall we put it? In X position of 40, a Y position of 120, and he's not going to be halfway over the screen. We'll just put the sprite there. Okay, let's get rid of these lines here. Okay, we'll save that. Let's see if that actually works. And no, it didn't. Okay, let me have a look and see exactly why. Okay, I can see one problem straight away. I need to load that in intermediate. I've loaded the memory address into the accumulator, not the number. Okay, so, and we need to do that here as well, and here. Okay, let's save that and try again. We'll take the breakpoint out. And there we go. So you might recognise the sprite there. That is Miner Willie from Manic Miner. So that's what I knocked up off camera in Sprite Mate. Okay, so he's white and the border's black. And, well, that high everyone is not very appropriate anyway. So let's just change this to Maniac Miner. So there we go. We're not quite copywriting everything. Okay. And there he is. Right, okay. The last thing we'll do on here is we'll put some code into just to move him. We won't do the joysticks or anything in this instance. I just want to get him moving smoothly, so I'll just get him moving down. Okay, so we can do that by decreasing the sprite X position. Okay, so what we want here, okay, you know I said there was a vars section. We can have bytes here, so we can have sprite 0 X position. So that was a byte of 40, wasn't it? Sprite 0 Y position. That's a byte of what we'll do with that, 120. Sprite 0 H X position. That's the high byte for that. That's really a bit, but I think we'll do that as a byte of 0. Okay. And we'll just change our macro here to, so it's sprite 0, sprite X position, Y position, and then sprite H X position. Okay, but obviously now we've done that, we're pointing it to memory addresses, not numbers. Then we will have to, on here, change this back to what it was, Y position. Okay, because we now we're pointing that at, that is a memory address now, not a value. So let's just make sure we haven't broken it. There he is, there's Willie. Okay. So all I want to do now for the last thing, okay, in this loop, I'll just decrease sprite Y position. Okay. So that will do that. Yeah, we'll just do a loop of that. Let's see how smoothly that's going. Ah, yeah, it's got to redraw the sprite, hasn't it? Okay, so this will actually set it properly. Okay, so in our loop we will. Okay, right. Oh, that is not very smooth, is it? Okay, so that's doing it before the screen refreshes, so that it's just unusable. Okay, so what we want to do now is we want another little screen routine or macro where we want to wait for the raster to get to a certain line before going back and doing the loop. Okay, so I think we'll do that in the screen macro file here. Screen wait for raster line, raster line number. Okay, this will be up to 255. Obviously, it won't be right at the bottom. Okay, so check Let's put a label in, check raster. Okay, load the accumulator with the address in raster line. Okay, CMP, compare that with raster line number. If it's not equal, branch if not equal, go back to check raster. Okay, simple as that. I mean, we should ideally use the MSB as well, so we can check from anywhere from 0 to 320. But for now, I'll just leave that as it is, just to test it. So let's go here, okay, and run it. Okay, that's still ridiculously fast. Okay, and the reason it is because we have not actually referred to it yet. Okay, so screen, wait for raster line. Oh, no, we've done our brackets. So what raster line should we write? Wait for, what do you reckon, 200 or 255? Let's go 255. That's better. Okay, he's looking much smoother now, but he's going in the wrong direction. Okay, so now look, he's been injected with helium. Okay, so let's, instead of let's ink the Y. Okay. Okay. So now he's falling. Okay. It's a little bit too fast. We can have a little timer in. Okay. Okay, so we want a bit more control over the speed that Willy sort of goes up and down or left and right. Let's put in a variable here. Now this is not, it doesn't get assembled. This is a variable. So every time the kick assembler sees this variable name, it puts whatever value is into the code. So let's have a speed of 5. Okay. And what we'll do is we'll have sprite 0 speed counter. Okay, and the byte of that will be speed. Okay, which is 5. Okay, so every time we put speed there, it puts the number 5 in. Okay, so what we're going to do down here, okay, where we increase the sprite, we're going to only do that every 5 goes through it, or however what speed is. Okay. Okay, so what we will do is we will decrease the sprite 0 speed counter. Okay. If it's not 0, we'll just call it timer used. Timer used. Okay, so if it's not 0, we're not going to do all this. Okay, so we'll put timer use. Okay. Okay, so what it'll do, it will check 5. Okay, it will decrease it to 4 if it's 0. If it's not 0, just carry on. Don't decrease at the Y position. If it is, it will edit the Y position. Okay, and then what we need to do after that is, if it is 0, okay, we will then load the accumulator with speed. Oops. We have to do it as +1 because obviously it's we're decreasing it straight away, and then store that into the sprite 0 speed counter. Okay, so if it's 0, it will move the sprite and then reset the speed counter back. Okay. Oh, and I don't want that there. Okay, and then it will just carry on as usual, wait for the raster line. So let's see if that makes a difference. Oh wow, that is slow, isn't it? Christ, that is very slow. Let's change that to maybe 3. So we just change it in one place. It's still fairly slow, isn't it? Okay. Yeah, that's pretty slow, but okay. We'll leave it at that for now. Okay. So we've got a nice library of routines already here, haven't we? So we've got stuff for turning sprites on, setting the X and the Y position. Okay, from an address. We've got some interrupt code here, some skeleton stuff that doesn't do anything yet. We could use that for sprite animations, that sort of thing, and music. Okay, and we can move our sprite around quite easily, just with a few lines here and a little loop. Okay. Okay, there's one last thing I want to do, which is going to be a precursor for the next video. Okay. Okay, so okay, so just here, before we get into this loop, I want to use some screen print text. Oops, screen mem, and then plus 24 times 40. Okay. Oh, it's often BG test instead of text. Okay. So we can see I've done that. Okay, the 24th line. Okay, I want that. There's 40 characters on a line. Okay, and same with the color mem. Plus, oh, let's do that. 24 times 40. Okay, so this is where we're going to position it, and we want that red. Okay, so if we run that, okay, we've got something that sort of represents some ground. Obviously, he goes straight through it, okay, when he's falling down. Right, so the next video in the series, we are going to try and be as pixel perfect as we can and detect when his sprite collides with the ground and stop him falling. Okay, so we're going to use what we call the bounding box, where we have points around the sprite where we check what character is the character number is on there, and then react accordingly. So I will leave it at this point here. We've got our macros and a nice collection of libraries. We'll obviously keep adding to them when we think of more things, particularly with this sprite collision that we're going to add on the next video. And I will see you on the next one.